If a rock is thrown upward in a planet Mars with a velocity of 10 meters per second, its height in meters t seconds later is given by y, which is equal to 10t minus 1.86t squared. In part A, we want to find the average velocity over the given time intervals. So you can see here that every time interval is starting at 1. And then this is 1 plus 1, which is 2. This is 1 plus 0.5, which is 0.5. This is 0.1, 0.01, and 0.001. So, in our first step here, we know that we have a value of t, and then the y value is t plus h. So, therefore, we have the following ordered pair. We know that t is equal to 1, and then we have 1 plus h. So now this being our ordered pair, then we can start our formula for the average velocity. And so the average velocity, according to this function for y, is y of 1 plus h minus y of 1 over 1 plus h minus 1. So let's go ahead and plug that in to our function. So we know 1 plus h is going to be the input. So we have 10 times 1 plus h minus 1.86 times 1 plus h squared minus 10 times 1 minus 1.86 times 1 squared all over 1 plus h minus 1. Okay, so let's simplify this a little further. We have 10 times 1 plus h minus 1.86 times 1 plus 2h plus h squared. And that's minus 10 times 1 minus 1.86 times 1. And we can eliminate in a denominator 1 minus 1, so we're left with h in the denominator. So now let's distribute and combine like terms. So we distribute the 10, we get 10 plus 10h minus 1.86 minus 3.72h minus 1.86 h squared. And that's minus 10 minus 1.86 divided by h. So let's combine like terms in our numerator. So combining like terms in our numerator, we have 10 minus 1.86, which is 8.14, and 10h minus 3.72h is plus 6.28h minus 1.86 h squared, minus we have 10 minus 1.86, which is 8.14, divided by h. So now we can eliminate the 8.14, and then we can factor out an h, which leaves us with 6.28 minus 1.86 h divided by h. So we can simplify the h, and then what's left is 6.28 minus 1.86 h. And therefore, there is our average velocity formula according to what h represents. And so keep in mind here that this is if h does not equal 0. So now in step number 4, okay, we know that we have h. And so the first one, h is going to equal 1. And then 0.5, 0.1, 0.01, and 0.001. So when h is equal to 1, then we want to find the average velocity for when we have 6.28 minus 1.86 times 1. So therefore, the average velocity is going to be 4.42 meters per second. So when h is now going to equal 0.5, and that is the interval from here, 1 to 1.5, then the average velocity is equal to 6.28 minus 1.86 times 0.5, and therefore the average velocity is going to be 5.35 meters per second. Okay, next, number 3, we have 0.1 for h. So when h is equal to 0.1, again, the average velocity is equal to 6.28 minus 1.86 times 0.1. And therefore, the average velocity is 6.094 meters per second. Okay, the next one here, number 4, we have h, which is 0.01. So when h is equal to 0.01, again, finding the average velocity, 6.28 minus 1.86 times 0.01. So the average velocity is 6.2614 meters per second. And then the last one, when h is going to equal 0.001, so the average velocity of 6.28 minus 1.86 times 0.001, and the average velocity is 6.27814 meters per second. So now the question is, estimate the instantaneous velocity when t is equal to 0. Well, as you can see here, from when it's 1 to 0.5, 0.1, 0.001, as h is approaching 0, so when instantaneous velocity when t is equal to 1, as h approaches 0, is 6.28 meters per second.